Hey guys, don't mind me, I got a bloody nose. So I'm training for ICPC, so time to get back on the grind. I got this book, that school book I'm reading, right here, and yeah, today I want to go over H-index. So the H-index is a pretty cool problem, and it goes like this. Let me just make a whiteboard, I guess. Yeah. So I have an array of numbers, classic, and I want to find a integer that has this following property. It is the largest integer, of which, let's say this integer is x. There are x plus values that are greater than or equal to x. So in this case, it's 4 because there are 4 values greater than or equal to 4. Now, this is not always obvious because if I have an array like this, the H-index is actually 3 because there are 3 values greater than or equal to 3. So, you'll notice some properties, like for example, earlier, if you saw that since 4 works, 3 also works as well because you can use the same values that are greater than or equal to 4 will also be greater than or equal to 3. So this is a monotonic property. You can use binary search to figure it out. But you'll notice that if you code out binary search, it takes a lot of time. Sorry, I brain farted. It takes a lot of time, so it's kind of annoying. But a neat little algorithm that only takes one for loop is basically you go through each number in the array and you see, okay, how many numbers are greater than or equal to this number? Well, in this case, there are 7 numbers greater than or equal to 1. That means the H-index could possibly be 1. That's true. Because there are at least 1 numbers that are greater than or equal to 1. Repeat this process throughout every single number. So 2 has 6 numbers that are greater than or equal to 2. This works. 3 has 3 numbers greater than or equal to 3. Or not 3. 4 numbers that are greater than or equal to 3, so that works. 4 has 4 numbers greater than or equal to 4, so that works. But 5 doesn't work. And once it stops working, you'll also notice if you flip the numbers around, for example, 5, there are 3 numbers greater than or equal to 5. But that also means 3 works. Does that make sense? Like 3 also works as an H-index. 6, there are 2 numbers that are greater than or equal to 6. So that means 2 also works as an H-index, but it doesn't fulfill the H-index property. So that becomes kind of neat because you avoid the problem of this situation where you have 500, 500, 500. So how many numbers are greater than or equal to 500? Well, there's 3 numbers greater than or equal to 500. But even though this property doesn't work, I know that there's 3 numbers greater than or equal to 500, so that means there's at least 3 numbers greater than or equal to 3. So because it has this monotonic property, you can connect the dots and say like, okay, yeah, that's greater than or equal to 3. So that's pretty much the algorithm. It's not that difficult to understand. Here's my code for it. I'm starting this whole GitHub repo because, I just want to make it organized. I hate this organization. So you got this, make an array, input, and sorting the array becomes really valuable because when you sort the array, it only becomes a O of 1 query to figure out how many numbers are greater than or equal to it. Because you'll notice that this array is sorted. How many numbers are greater than or equal to 4? Well, that's actually the number of numbers that are right or to the right of it. And you can get that number by doing n, which is the total number of elements minus the current index. So, pretty neat. I said that all really quickly. I'm kind of rusty in teaching. But here, the number of numbers greater than or equal to vi, which is my x. That is this, n minus 1. And then how many numbers, or sorry, this is n minus 1. If the number of numbers, or the number of values, is greater than or equal to this value, that means I'm going to, that is a h-index that is valid. It is a valid h-index. But if it doesn't work, like in this case, well, I also know that this is a valid h-index. So the number of numbers greater than or equal to also works. So that's my answer. It's O of n log n because of sorting, but the actual like algorithm part of it, it's not really like you code it on your own, is O of n. But yeah, and then that's it. This is my first video in a while, but I'm gonna make a video every day. I coded this yesterday, or I solved it yesterday, so I'm gonna make another problem today. But I'll see you later, and yeah.